Hi everyone. So today we're taking a look at some more properties of exponents. We're going to be taking a look at the quotient rule. So let's start off with the definition. The quotient rule states that if you divide powers with the same base, you subtract their exponents. So here we have an example so I can show you why the quotient rule works or why we subtract the exponents. So we have 3 to the 5th divided by 3 to the 2nd. So if I were to simplify this, I know that 3 to the 5th is 3 times itself 5 times. So if I write that out, 3 times 3 times 3 times 3 times 3, and I divide that by 3 to the 2nd, so that's 3 times itself. This would be the expanded version of this fraction. Now if I wanted to simplify that, I can cancel some of the terms in the numerator and the denominator. So if I cancel those, this 3 would cancel with this one, this 3 would cancel with this one, and what I notice is that I have 1, 2, 3 3's left in the numerator. So that's the same thing as saying 3 to the 3rd. Well, the way that that works, we'll do that off to the side, is 3 to the 5th over 3 to the 2nd is the same thing as saying, or subtracting the exponent, so it's the same thing as saying 3 to the 5 minus 2, which equals 3 to the 3rd. So this works kind of like what you guys saw yesterday with the product rule. When you're multiplying with the same base, you add the exponents. When you divide with the same base, you subtract the exponents. Now, something that I want to note here, because a lot of times students, especially when the bases are small, students like to actually evaluate the numerical value first. And I want to stray you away from that, because an issue that you're going to run into is something like when you have larger bases, it's going to be difficult to evaluate. Or next week, we're going to get to working with exponents with variable bases, and you're going to run into an issue there. So please take note that when you're multiplying or dividing with exponents, combine the like bases first. Do not evaluate. You want to add or subtract the exponents, but do not evaluate. Your final answer should have an exponent in it, okay? So for example here, what students tend to like to do is say 2 to the 4th, we know that that's 16, and 2 to the 2nd becomes 4, so I know that this simplifies to 4. Now the issue that you run into is when you have larger bases. If I go to type 12 to the 100th into a calculator, let's see what the calculator is going to say. Okay, so let me just focus so you guys can see. If I type in 12 to the 100th, that number is too big for my calculator to even calculate, so I run into an issue. So that's why we want to work with our exponent properties and simplifying using the exponents and the like bases. So if I wanted to simplify 12 to the 100th over 12 to the 98th, I could do so like I did up here. And I could write this as 12. Because we're dividing with the same base, we're going to subtract the exponents to the 100th minus 98. So this is the same thing as saying 12 to the 2nd, which if you would like to evaluate at the end, you can. Especially when we're working with variables, you're not going to need to, so this answer is totally fine. You don't have to actually evaluate that number, okay? So just make sure that you're evaluating with the same base. So if I wanted to write this with base 2, that would be the same thing as 2 to the 2nd. Okay, so today we're focusing on dividing with exponents that have the same base and how to simplify that. I just wanted to go over a couple examples of what to do and what not to do, and just make sure that everyone's on the same page. So let's move down to the examples. So for our examples today, we want to simplify the following completely. Your answer should only contain positive exponents and one term with each base. So that means my final answer shouldn't have 2 base 7s. I want to simplify that because they have the same base. So using our quotient rule, we have 7 to the 15th divided by 7 to the 10th. That's the same thing as saying 7 to the 15 minus 10, which will give us 7 to the 5th. Again, since next week we're going to be focused on variable bases, you could definitely leave this as 7 to the 5th. You don't need to evaluate that. Okay, moving on to number 2. Now, what's a little bit different here is we have 2 different bases. We have a base 3 and a base 4. So what we're going to do is simplify the like bases. So I'm going to simplify the 3 to the 7th and the 3 to the 4th. Remember, because we're dividing, I'm going to subtract exponents. So 7 minus 4 is 3. So this is the same thing as saying 3 to the 3rd. And then because we only have one base 4 in my answer, I'm just going to have a 4 to the 5th. And that would be my final answer. For number 3 here, we have 2 of the same base. We have a base 2 and a base 5. So I'm going to pair up my base 2s and pair up my base 5s. Now, one thing I want to point out with the base 5, here you don't see an exponent, so pretend there's a 1 there, so it's 5 to the 1st. So I'm going to simplify this as 2 to the 9 minus 8, because the numerator's exponent is a 9, denominator is an 8. And I'm going to be multiplying that by 5 to the 3 minus 1. Again, it's the numerator exponent minus the denominator exponent. I'm going to simplify that. 9 minus 8 is 1. So this is 2 to the 1st times 3 minus 1 is 2. So times 5 to the 2nd. So that would be our final answer. Again, we can leave it so we have exponents in our answer, because when we're working with variables, we're going to want exponents in our answer. There's going to be no way to simplify that. All right, taking a look at our last example, we get a 3rd color. Okay. Let's start by pairing our bases. So we have a 6 to the 3rd divided by 6. Remember, even though you don't see an exponent there, that's to the 1st. So we're going to pair these. And we have a 4 to the 8th divided by 4 to the 4th. And then a 2 squared divided by 2 squared. Now, for this one, because we have 2 squared divided by 2 squared, that's the same number. Those are just going to cancel in both the numerator and the denominator. Okay, so really all we're going to have to do is simplify the base 6 and the base 4. So we're going to have 6 to the 3 minus 1 times 4 to the 8 minus 4. And we're going to simplify that. So 6 to the 3 minus 1 is 6 squared times 4 to the 8 minus 4. 8 minus 4 is 4. So 4 to the 4th. And again, we can leave that as our final answer. Okay, guys, that is everything for today for the quotient rule. Please finish up the last few problems on your weekly assignment that deal with dividing with common bases. And you will have an Edge Elastic assignment tomorrow to assess you on everything we did this week.